Hello and welcome to Skyworks Power over Ethernet Basics mini-series. My name is Gábor Valentin Csutár, Skyworks Application Engineer, and today we will talk about POE/PD's classification function. First of all, let's see what classification actually means when we talk about Power over Ethernet. After a successful detection, PSE transitions to the classification stage. If you are not familiar with detection, please take a look on our previous video, POE Basics Detection. Classification is the process when power sourcing equipment, or PSE in short, and power device, or PD, negotiate the power needs of the PD, which needs to be provided by the PSE. At this time, classification has 4 types, from type 1 to type 4. This type determines the main static characteristics of the system. Type 1 and Type 2 systems are operating with 2 pairs, while Type 4 systems are using 4 pairs. A Type 3 PSE can work with both 2 and 4 pairs, depending on the power needs of the PD. Under types, we also differentiate 8 classes, which represents an increasing power level as you can see in the second figure. The class determines the maximum power of the system. As you can see, within a class, there are different power levels for PSE and PD. The maximum length of an Ethernet cable is 100 meters, where we have a significant voltage drop. Hence, PD's power level is lower than PSE's. For example, if you have a 100 meter long cable, a Type 2 Class 4 PSE, with a maximum power of 30 watts, on the other side of the Ethernet cable, the maximum power of the PD will be 25.5 watt. Discussed about types and classes, now let's talk about classification in more detail. After a valid PD is detected, the PSE interrogates the PD to find its power requirement. This mutual identification allows PSE to determine the type of PD, while the number of pulses allows PDs to differentiate between PSE types as well. PSE is producing a certain amount of class events to a PD, which responds by producing its class signature for each event. We call this physical layer classification. If there is no physical layer classification implemented by PD, current draw is less than 5 mA, we talk about class 0 classification. A class 7 means that PSE applies a voltage between 15.5 watt and 20.5 watt for time specified in the IEEE 802.3 standard, which is about 30 milliseconds. A class event is followed by a so-called mark event. During mark event, PSE must apply a voltage between 7 watt and 10 watt, so it can be simply differentiated from class event. This event serves as a message that a class event has occurred. It helps to identify the length and the number of the class events. Let's see an example. In the left figure, we can see the voltage and current waveforms of a Type 4 Class 8 system. To see how many class signatures produced by the PD for each classes, we can take a look on the table on the right side. As you can see, after a successful detection, the voltage goes up to the class 7's voltage range, then decrease the voltage level to the mark range to designate a class event has occurred. In case of a class 5, 6, 7, or as in this case class 8 identification, after 2 class 4 signatures, the current in the following class events will be in the corresponding class signature range. In this case, there are 3 types of class 3 signatures. I hope you are a little bit more familiar with Power over Ethernet's classification feature. For further information, please visit skyworksin.com. Thank you, and I wish you a good rest of your day.